So this question is asking us to draw a box plot, and to draw a box plot then we know that the general picture of a box plot is a box with two whiskers on either side, where the end whiskers are the minimum and maximum values, and then the start of the box is the lower quartile, in the box itself is the median, and the end of the box is the upper quartile value. So LQ is the lower quartile value, and the UQ is the upper quartile value. So this is the min. So the minimum is 5, the maximum is 44. The list is already in size order. If it wasn't, then you must make sure you put it in size order. And then we find the median next, and the median is the number in the middle. There are 15 numbers, so we add 1 to that 16, so the middle number will be half of that 8, so the middle number will be the 8th number. So 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be our median. And the lower quartile is what it is. It defines itself as a quarterway. So we have 1, 2, 3, 4, 5, 6, 7 numbers up to the middle. Add 1 to that 8, halve it 4. So our lower quartile will be the 4th value. So 1, 2, 3, 4 is the quarterway. So that's our lower quartile. And then from the other end, 1, 2, 3, 4, that's going to be our upper quartile value. So you plot these as dots. So the minimum was 5, so we look at our scale. Every square is worth 1, so that's quite a nice simple scale to use. So 5 goes there, 14 goes there, 25 goes there, and 30 goes there, and 44 goes there. And we use our ruler to make sure we make it neat and tidy. So put our whiskers on, draw up to the quartile values where the box will be, and then of course we draw a box. Doesn't really matter how big the box is, just make it a reasonable size so you can see what's going on. And then we draw the median value. So that will be our box plot drawn with the box of the whiskers, minimum, lower quartile value, median, upper quartile value, maximum value. The question then goes on to say the box plot shows distribution of times that we want to say that the grid has been set. So this is another box plot. So this is roses, so label it so it can be clear. And this is served at greens. So we're comparing roses and greens box plots. So when you compare box plots, you look at two values. So it's the question's worth 2 marks. So they're looking to make 2 comparisons. It's got that word compare. So we're looking for the median value, the median average, and we can see that for roses it was at 25 seconds, and for the greens the median was equal to 21 seconds. So the first comparison is to say that on average people waited for less time at greens due to the median. So on average people waited for less time at greens due to the median average being lower at 21 seconds. And then the other comparison that you should be making is about the spread of the data. And you've got the ordinary range and the data, but also you've got the interquartile range. Now the better one to use is the interquartile range, because that ignores extreme values, because up here we've got quite a stretch, so there might be just one value that kind of skews the range here. So we can calculate the interquartile range to give us an idea of the spread of the times for the middle 50% of the data. So for this one, the interquartile range is equal to the upper quartile value minus the lower quartile value. and the upper quartile value here is 30, and the lower quartile value we calculate as 14, so 16 seconds is the interquartile range, and the interquartile range for this one is 35 minus 12, which is 23 seconds. So again, we've got one comparison there, and now we can compare the interquartile range, and we can simply say that green's interquartile range was larger, showing the times for the middle 50% of people was more spread out. So in other words, their interquartile range was larger, which suggests that the times that people wait is more spread out, although the average suggests that they are typically quicker for the 50% point, halfway point. So that's box plots and how we compare them. Other comparisons we could have done at the bottom here is that we could have said that green's box plot shows positive skew, and rose's box plot shows negative skew. So we could have compared the skew by the way the box plots are drawn. The median being further up shows that this one's got negative skew, and the median being lower down in the halfway point of the box shows that this one's got slight positive skew. So that's again something we can do with box plots. We can compare the skew, we can compare the average, the median average, and we can compare the interquartile range or the ordinary range as well. So there's lots of ways we can compare.